Hi everyone and welcome back. So we are starting our next unit. We're actually going to be talking about conics, so different conic sections. And one of the conic section cross area pieces would be a parabola. So what I mean by conic sections is if I were to create two circular cones, one of the conic sections, if I wanted to sketch in, would be a parabola. You could sketch in a parabola. We also have a circle, would be another one of the sections. We have hyperbolas, which we're going to get to. So that would look something like this. All right, so that's what a hyperbola would look like. And we're going to get to all of these in our upcoming topics. But these are just a few examples. So you would have a hyperbola that would look like this. Again, that dotted section just to show the crossover. We have circles. We'll have actual ellipses as well. We have parabolas. All right. So those are just different conic sections of a cone. So that we have a right circular cone. Okay. So first things first, let's take a look at what our do now question is. So this is actually something that you guys should remember from geometry. What's the distance formula? Does anyone remember what the distance formula is from geometry? So our distance formula is actually, we have distance is equal to the square root of the change in x squared plus the change in y squared. So we'll have x2 minus x1 squared plus y2 minus y1 squared. All right? So this is my formula for the distance formula. Now, my next question is I want you to sketch the locus of points that's equidistant from the point and the line below. Now, this may not be as intuitive to you, but I actually want to come up with drawing a sketch here. So we want it to be equidistant from the point and the line. So from the point and the line. Well, if I draw something here, right? This is equidistant from the point and the line. Let's continue that. All right, well now if I look over here, this distance that I just sketched in is equidistant from the point and the line. Okay, let's continue with that pattern. What about here? That would be equidistant from the point and the line. Can you start to tell what shape that this is creating? This is a parabola, guys. So focus and directrix is something you learn about in Algebra 2. So what we're going to be actually focusing on today is the parabola. And knowing how each piece here, and I'm going to sketch that again, that's actually going to be really important. The distance from here to here is equal to each other. So we have from here to here, they're congruent. If I were to go from here to here, these are also congruent. Just, be mindful. Obviously, this is not drawn to scale from my picture, but this is a true statement for all parabolas. So where we call this part here, that would be my vertex. This line here would be the directrix. And then this point here is the focus. Three really big key pieces here. Okay? So let's go through some more definitions and vocabulary. So conic equations for parabolas, these are just 4 different equations that you are going to want to know whether it's opening upwards, whether it's opening downwards, so that would be this way, whether it's opening to the right, so that's a sideways parabola, and then opening to the left, that would be a sideways parabola opening to the left. Okay. So, given the parabola centered at the origin with a focus at 0, 8, we're going to actually derive the conic form of a parabola. So, we're going to actually derive the equation for a parabola in its conic form. So, let's take a look at the pieces that we have here. I'm going to highlight these in different colors just to help keep us organized. So, I have the distance from FP, as we saw from before, to PA are congruent. Again, I'm sorry this is not drawn to scale, but these pieces are congruent, as we saw from up here with our parabola. Okay, from here to here is congruent. So that's the same thing that we're looking at. From that point on the parabola to the directrix. From the point on the parabola to the directrix, they're congruent. Okay, well, let's write that out. So we know that these two distances are congruent. So I know the distance of F to P is equal to the distance of P to A. Really P to D, because that's the directrix, so P to D. Okay, well, we know what the formula is for the distance formula, right? So if I'm looking at from F to P, so if I'm going from F to P, I'm going to use my distance formula, which is the square root. We have change in x squared, so I have x minus 0 squared plus y minus a squared, right? Change in x squared plus the change in y squared. All right, and the distance from P to D is, well, we have these two pieces here. We have this is y, and then this is a. So we're going to add those together, y plus a. Now I'm going to square both sides to get rid of the radical. So we're going to square this whole thing and square this. So we'll have x squared, because x minus 0 is just x, and then it's being squared, plus y minus a squared equals y plus a squared. I'm just going to simplify this. We'll have x squared plus y squared minus 2ay plus a squared is equal to y squared plus 2ay plus a squared. Now, if you notice, on both sides of the equation, there's both a y squared, there's both an a squared, and I'm left with x squared minus 2ay equals 2ay. Going to add over the 2ay, and I'm left with x squared equals 4ay. I can rewrite this, because this would be the exact same thing, because we're going to want to use our vertex. So my vertex is at 0, 0. Using what we have up here, this is a upwards facing parabola. So I'll have x minus 0. We use the x value of the vertex, which is 0, squared is equal to 4a times y minus 0, because that k value is the y value of the vertex. And there you guys have it. We just derived the parabola formula from a conic. Okay? All right, let's keep going. So this was just our derivation. I want to take a look now on the next page. Again, I do apologize. This is very not drawn to scale. My apologies. This Directrix line should have been much higher up than when I had created it. But anyways, just as a reminder, okay, the distance from the focus to a point on the parabola, and then from the point on the parabola to the directrix, these lengths are equal. Again, hence notice not drawn to scale. Very, very sorry, not drawn to scale. Really, if I were to have drawn this over here, give you a better sketch of a parabola. Here's my directrix. Here's our focus. We'll go from here to here, and that's way more accurate if you could see. All right, where those two pieces are equal. Apologize for the not drawn to scale aspect, but hopefully you understand the point. In addition, I have just covered also some basic vocabulary and definitions. So when our a value is greater than 0, it's going to be concave up. If it's less than 0, it's concave down. Very important, actually, we do talk about this. The Latus Rectum is the absolute value of 4a. So where that comes from is from the focus to one of the endpoints of the parabola to then the other endpoint of the parabola. So if we take the midpoint, being the focus, and we extend from the focus exactly towards, so at 90-degree angle, the point on the parabola, and then again from a 90-degree angle from the focus, with the focus being the midpoint, to the other point on the parabola, this length from here to here is 4a, where a is the distance from, so a is the distance from the vertex to the focus, vertex to the focus, and then also from the vertex to the directrix. So these both have the same length values. All right, really important vocabulary, and make sure you have this stuff written down and highlighted as well. Okay, so let's go on to the next page. So we have x squared equals 8y. Now, I'm just going to write down my basic formula that we derived earlier, which was x squared equals 4ay, where it's really x minus h squared, where h is the x value of the vertex. X value of the vertex is equal to 4a y minus k, where k is the y value of the vertex. Okay, so vertex in this situation, we're going to figure that out. We know what? What can we tell from this formula that we're given here? We have x squared equals 8y. Well, if you look, x squared equals 8y. Notice that 4a can be replaced with 8. So I'm going to write 8 is equal to 4a, which then tells me a equals 2. So because a is greater than 0, we know that this is concave up, obviously, as you can tell also too from the picture, and we have a equals 2, right? It's already concave up. So just verifying that we have this done correctly. If I know a is equal to 2, well, from there, I can fill in the following pieces. I know this distance from here to here is 2, and this distance from here to here is 2, which tells me what? Well, before I can assume, you don't want to assume anything. So before I can verify anything about the vertex, I want to actually go back to this equation here. I could rewrite this equation as x minus 0 squared is equal to 4a times y minus 0, indicating that my vertex is at 0, 0. So I already actually know the vertex is at 0, 0. So if this vertex is at 0, 0, we know the focus, because it goes up by 2, is at 0, 2. And then the directrix, because we're going down by 2, is at y equals negative 2. The lattice rectum, remember, that's the difference from once we find the focus as our midpoint. So let me just erase this here and here. We know the focus has a coordinate point of 0, 2. All right. So we know, let's see here, that this distance from here to here is 2a. And then this distance from here to here is 2a. If a equals 2, well, I know this is going to be 4, and this is going to be negative 4, because we're going left of on the x-axis. So if I asked you to come up with the endpoints, well, this is then the point negative 4, 2, and then 4, 2. So I have negative 4, 2, and 4, 2 are the endpoints. And if I asked you to just come up with the lattice rectum by taking the absolute value, well, for the lattice rectum, we're taking the absolute value. I'll write that up here. Absolute value of 4a. And we know a equals 2, so it's just 8. Okay? Hopefully that was a little bit of clarification there. Let's take a look at another example. Let's take a look at x squared equals negative 10y. So again, we already actually can tell from the picture this is concave down, so we know a is going to be less than 0. So I better get an a value less than 0 when I do this. We have x squared equals negative 10y. I'm going to rewrite this using my formula. X squared equals 4ay. So I can substitute in here. We're going to set negative 10 equal to 4a. So I have negative 10 equals 4a, where a is going to equal negative 10 over 4, which simplifies to negative 2.5, which confirms that this is concave down. A equals negative 2.5. Okay, so then I know that this distance from here to here is 2.5, distance, and then the distance from here to here is 2.5. Let's figure out what the vertex is. Well, I can rearrange this equation to read as x minus 0 squared is equal to negative 10 times y minus 0, where there's my vertex at 0, 0. Take those h and k values. So my vertex is at 0, 0. So this is right here, my vertex. I know the focus is down 2.5 units, so I'm at 0, negative 2.5. The directrix is above by 2.5 units, so that's y equals 2.5. If I asked you to find the endpoints of the lattice rectum, so endpoints, well, remember, this distance from here to here is 2a, distance, and the distance from here to here is 2a, from the midpoint of the focus to then the endpoints of the parabola. All right, so we know twice 2.5 would be 5, and then this would be negative 5 because you're on the left-hand side. So I'm looking at this point here being negative 5, negative 2.5, and then this endpoint here being positive 5, negative 2.5. So those are my endpoints for the lattice rectum. Let's write that out. We have negative 5, negative 2.5, and 5, negative 2.5. If I asked you to just find the distance, that length for the lattice rectum, we know that this whole distance from here to here is 4a. So we take the absolute value. So we have the absolute value of 4 times negative 2.5. Take that absolute value, and you end up getting 10. So that would be the length for the lattice rectum. Okay? All right, let's go through a few more. So we did obviously already concave up, concave down. What do you think is coming next? Yeah, we got to do those sideways parabolas. So let's take a look at our next example. We now need to consider y squared equaling 4ax. For when it's up and down, we're looking at x squared equals 4ay. When it's sideways, we're looking at y squared equals 4ax. And again, we're just following our formula. So if it's sideways, I have y minus k squared, be careful, it's k now because we're taking the y value of the vertex, is equal to 4a times x minus h. H comma k, remember, h comma k is the vertex, that's the y value, and then h is the x value. So you need to make sure that they pair up correctly. So notice h is the x value, so it stays with x. So x and h go together. And then I have my y value is k, so notice I have y and k paired together. Just keep that in mind. Careful little fix. So now if a is greater than 0, know that that's going to be opening to the right. So when a is greater than 0, we open to the right. When a is less than 0, we open to the left. So if you look at the first example, we're opening to the left. So this better be less than 0 when I calculate a. In this situation now, from here to here is a, from here to here is a, from here to here is 2a, and from here to here is also 2a. Remembering this total distance for the lattice rectum is 4a. So this is our new setup for the sideways parabola. Let's come up with what the vertex is using our new formula for a sideways parabola. So I have, from this example, y squared equals negative 16x. So we can rewrite this as y minus 0 squared equals 4a times x minus 0. And remembering, this 4a is that negative 16. So this is actually negative 16. So off the bat, if this is 4a equals negative 16, I know a equals negative 4, which is good because we said a had to be less than 0 anyway, so that's checked off. We know the vertex is at 0, 0, so 0, 0. So we know that my vertex is at 0, 0, that's a V. Okay, the focus, well, if I know a is at negative 4, I know the focus, this coordinate point, will be negative 4, 0. My directrix, I go 4 units now to the right, is that x equals 4, because we have a vertical line here. Okay. And guys, and if I'm moving too quick or anything, just know you can always pause the video and rewind, fast forward, whatever you need. All right, so the length of the lattice rectum, remember, is 4 times a. We take that absolute value. So I have the absolute value of 4 times -4, which is 16. Last thing that we want to check are just the endpoints. So now my endpoints for the lattice rectum are here and here, where this point is at -4, 8, and this point is at -4, -8. I'm just using the fact that the y value gets doubled by a. So we have 2 times a and then 2 times a to get the y values. So those are my endpoints. -4, -8, and -4, +8. Okay, now that we talked about opening leftwards, we now need to talk about it opening rightwards. So when it's opening rightwards, we already said this, hopefully, and this better be greater than 0. So let's go in and check. First, we want to get this set up in the right form. We want this to be y equals 12x, which we can rewrite as y minus 0 squared equals 12 times x minus 0. Again, noticing the vertex is at 0, 0. If I look, my a value, remembering this is equal to 4a. So I have 12 equals 4a, which means a equals 3. And a is greater than 0, so that's good. Last thing we want to check here. We have the focus. So remembering this distance from here to here is a. This distance from here to here is a. So we know our vertex is at 0, 0. We know the focus, we're moving by a distance of a from the origin, is at 3, 0. And then the directrix, we're moving in the opposite direction. So that's x equals -3. Remember, it's that vertical line. X equals -3. The formula for the lattice rectum, remember, is from the endpoints. For the midpoint being the focus, we take the endpoints in the parabola. So we have the absolute value of 4a, which is the absolute value of 4 times 3, and that's 12. And then we just want to check what the endpoints are. So remembering the distance from the focus to one of the endpoints of the parabola is 2a, and then from the focus to the other endpoint of the parabola is 2a. I already know this x value is 3, so I'll have 3, something and 3, something. I know that I'm moving downwards by 2a and upwards by 2a, where a is equal to 3. So I have 2 times 3 is 6, 2 times 3 is 6, but we're moving in the negative direction, so that will be -6. So those are my endpoints for the lattice rectum. Now we've covered all 4 different situations you could see with the parabola, with it being facing upwards, facing downwards, facing left, or facing right. Now we're going to get into some practice problems. So I want to take a look at this first question here, where it says, applying the conic equation problems, always sketch it out, which is true. You really are going to want to always sketch these in order to correctly know what you're looking at. Otherwise, these are really hard to solve. A visual is always really helpful. So we have which equation represents the set of points equidistant from the line y equals 1 and a point to -3. So I'm going to sketch. Okay, so I have the line y equals +1. So that would be here. So y equals 1. So there's my directrix. And then I'm looking at the point 2. So 1, 2, -1, -2, -3. So I'm looking at the point right here. 2, -3. So remember, when we have the point that's equidistant from the line, what we just found out, given this information, and if you think back to actually the very beginning, we just found out what the focus is. All right, so if I come all the way back up here, where we just talked about this, which part would be equidistant from the point and then the line? Well, given that point, we were given the focus, and then this line was the directrix. So that's the exact situation we're looking at. So we have right back here, we have the focus, which is given with the point, and then our directrix. All right, so if I know the directrix and the focus, I can figure out the vertex. Because if you remember from our sketch from earlier, that vertex is halfway between the focus and directrix. So let's see, how far are they apart? So let's go. We have a distance of 1, 2, 3, 4. So that's a total distance of 4 units. So that means halfway would be a distance of 2. So I'm going to go either up from the focus or down from the directrix. So let's go up from the focus 2 units. So let's count that out. That's 1, that's 2. So there is my vertex. So that's my vertex of, we went up 2 units. So I'm at 2, -1. Okay, so I know the vertex. That's very helpful. Now let's come up with our generic equation. And to come up with our generic equation, I'm actually going to sketch out this parabola. This is the vertex. Remember, with the parabola, with the focus and directrix, the vertex is our either maximum or minimum. We're never going to cross over the directrix. So this would be wrong. So let me erase that. We're never going to cross over the directrix. So I know then my parabola has to be facing down, which means I know that my A value will be less than 0. So if we traveled a distance from the vertex to the directrix as a distance of 2, and then the vertex to the focus as a distance of 2, we know A is equal to -2 because we know A has to be less than 0. Okay, keeping all of that in mind, I'm going to come up with my generic formula for a up and down, either concave up or concave down, parabola using that conic form. So we have x squared is equal to 4ay, and I know the vertex. So this is my h, this is my k. So I'll have x minus 2 squared equals 4 times -2 times y plus 1. So let's simplify this. We'll have x minus 2 squared is equal to -8 times y plus 1. And I want to get it to look like this form. So notice for all of these equation answer choices, y is by itself. I'm going to distribute. I'll have x minus 2 squared is equal to -8y minus 8. I'm going to divide everything by -8. So if I rewrite this, I have x minus 2 squared over -8 is equal to y plus 1. I am going to subtract 1 on both sides. So let me rewrite this, clean this up. We'll have y equals -x minus 2 squared over 8 minus 1. That's my final answer. And that represents answer choice, drumroll please, D. Okay, let's move on. So I actually want to take a look at question numero trace here. So number 3, we want to find the directrix and the focus of the parabola whose equation is given. So we have the equation y squared equals 8x. You need to recognize we're dealing with now a sideways parabola. And we're going to figure out whether it's facing right or facing left. So I'm going to write out the general equation. We'll have y minus 0 squared, that's equivalent to 4a times x minus 0. Now, we know the number in front of x is 8. So right here, this is 8. So I know 4a is equal to 8. So I know a equals 2. Well, because a is positive, this thing is going to be facing to the right. So let me sketch that out. We know the vertex is at 0, 0. So my vertex is at 0, 0. We know this thing is facing to the right. A is equal to 2. So the focus is going to be 2 units to the right. So there's my focus at 2, 0. The directrix is the opposite direction from the vertex with respect to the focus. So if the focus goes to the right, directrix is going to be on the left. So we're going left 2 units. Draw on my directrix, and that's at x equals 2. So I actually just found everything that I needed. So my focus is at 2, 0, and my directrix is at x equals -2. And that's everything this question asks for. All right, well, that's cool. Another question I would like to take a look at is question 6. So we're going to find the directrix and focus of the parabola given the following equation. Now, this requires us to remember how to complete the square. So what we're going to do is I'm going to write this out as x squared plus 4x plus blank, and then minus the 4y equals that plus blank on the right-hand side. I'm going to bring over this 4y just to make this a little easier to look at. So I have x squared plus 4x plus blank is equal to 4y plus blank. Remember, we did this early in the year, completing the square. We have the b term, so plus 2, and then square it. So plus 4 and plus 4. I'll have that equals 4y plus 4. If I factor out on the right-hand side, I'll have x plus 2 squared is equal to 4 times y plus 1, which is in the correct form. So we know this is in our conic form for a parabola. So we know that the vertex is going to be at -2, -1. So let's write that. So the vertex is -2, -1. So that's -2, -1. That's about here. So there's my vertex. Okay, what else do we know? We know, well, remember the standard equation is x squared equals 4ay. So from here, we know if that's 4a, well then a equals 1. So that's positive, so we know now that it's going to be facing upwards. So a is positive. So that means there's a distance above and below the vertex of 1. So if this point here is -2, -1, we know the focus is going to be 1 unit above. And we know that the directrix will be 1 unit below. So this point here is our focus at -2, 0, and my directrix is at y equals -2. So those are all the pieces. It asks for what's the directrix and the focus. Directrix is at y equals -2, and then the focus is at -2, 0. Last question I just wanted to take a look at for the day, if we go back up, was question number 4. So the question says, what are the focus and directrix of the given function? So this is our parent function. You guys are so used to this. Just regular y equals x squared. That's a quadratic. All right, you already know that your vertex is at 0, 0. And I'm going to rewrite this as x squared equals y, where we have x minus 0 squared equals 4ay. We're writing it in that form, that conic form. Okay. And we know that we can actually write this as y minus 0 because the vertex is at 0, 0. We also know that there is only a value of 1 in front of y. And if the equation is 4a times that quantity of y minus 0, well, we are going to set these two pieces equal to each other. So I'll have 1 equals 4a, where a is equal to 1/4. All right. If a is equal to 1/4, then that means I know the distance above and below the vertex is a distance of 1/4. So this point here as the focus is going to be 0, 1/4. And then the directrix, so that's 0, 1/4. And then the directrix is going to be at y equals -1/4. Thought that's pretty interesting. I don't know if you guys have seen that before. Probably saw it in Algebra 2. Maybe you forgot, maybe you remembered. So we have our focus is going to be at 0, 1/4. And then the directrix will be at y equals -1/4. So that's just from the parent function, actually, of a quadratic. I don't know, I thought that was pretty interesting to show you. Okay. Last part, to conclude our lesson, we want to describe the sequence of transformations that would take the graph of f of each parabola described below. So if the focus is at 0, -1/4, so if the focus is at 0, -1/4, and then the directrix is at 1/4, what's going on here? So I'm going to draw this in green. So now they're saying move the focus down here and then move this directrix up above. Well, what we're looking at then is the following picture. Right, there's my vertex, and now the focus is here. Well, now that thing was just reflected over the x-axis. So this is just a reflection over the x-axis. Okay, now our next piece is saying that the focus is now at 1/4, 0, and the directrix is at -1/4. So if I make a sketch, now the focus is at 1/4, 0, so there's the focus, vertex is still here, so now we're sideways, and the directrix is at -1/4. Well, all we did was just rotate this by 90 degrees clockwise, or 270 degrees counterclockwise. So this is a rotation of 90 degrees clockwise, or a rotation of 270 degrees counterclockwise. All right? Something, a little small piece of information to remember. When we're clockwise, there's a negative sign out front of the angle to indicate that it's clockwise. Counterclockwise, you leave it as positive. All right, and last one. Now we have the focus is at 0, 0. So if the focus is at 0, 0 now, well, the vertex had a shift. You can't have the focus and the vertex being the same thing. So if my focus is at 0, 0, we're going to move the vertex now to 0, -1/4. And so that's my vertex, there's the focus. And the directrix will now be located a little bit farther down. So now that would be at y equals -1/2 instead of being at -1/4. So everything really, all we did was just translate down by 1/4. So in this last part here, find a conic equation for each parabola described from this question here. Well, for letter A, that's just a reflection over the x-axis, so that would be y equals -x². For letter B, we just rotated it by 90 degrees, so we're going to switch x and y. So we have y² equals x. And then for letter C, we have the focus was now at 0, 0, and the directrix was at -1/2, meaning that this was translated down by 1/4. So we have y equals x² minus 1/4. Or if you'd like to write it as x² equals y plus 1/4, both of these are equivalents and the same. All right, guys, I hope you found this video helpful. I know it was a little bit lengthy, but there was a lot of definitions and recalling of information from Algebra 2 that I want to make sure that we remembered in terms of focus and directrix. All right, I'll talk to everybody soon. I hope everyone's doing all right. Bye.